Start with a new session on polynomials. Previously we learnt about the zeros of the polynomial. Herein we'll move towards learning this remainder theorem. Before doing so, let us learn how to divide two polynomials and find the remainder. We'll learning actually be dividing a polynomial with a linear polynomial. Suppose px is a polynomial which is being divided by another monomial, or suppose a linear polynomial by gx. So that the one which we are dividing, which we generally call as the dividend, and the one which we are dividing that px, which is called the divisor, here is termed as gx. The question might just be asking, where is your px is given by x4 minus 3x to the power 2 plus 2x plus 5 is to be divided by the gx, which is given as x minus 1. Here we will be directly dividing these polynomials. Later on, once you learn about the remainder theorem, you can directly find out the remainder. Here we are actually looking forward to find out the remainder. There is no third degree x here, but I'll leave some space and write it either as 0x cube or leave some space, because once you multiply, I'll come across a degree x, and in that case it would be difficult for you to write it below. Now here it is x minus. We are looking to keep cancelling each and every term. So the first term in x4, if I multiply an x cube here and multiply x cube with this whole of x minus 3, I'll be getting x4 minus 1x cube, or simply I can write an x cube as well. So we change symbols. Why? Because in division what we do is, to find the remainder here, we subtract this top one minus this one below. So ultimately what happens, if I'm writing it in rough here, just to explain you, minus of this, then the symbols get changed. It ultimately would become x to the power 4 0x cube minus x4 plus x3. Keeping this in mind, we can just simply change the symbols here below. That means we are subtracting these two terms. I'm sorry. So the one which is here plus becomes minus, and the minus here becomes a plus. Thereby this 2 gets cancelled, and here it becomes 1 plus 0, it's 1x cube. Rest of them will be brought down. I think this I have written a mistake. Plus x. Now we are looking to cancel x cube. So if I multiply 1x square with x minus 1, I would be getting x cube minus x square. Then again we need to change the symbol because of the same reason as explained before. It's minus 2x square plus 2x plus 5. Now I need an x square here and a minus 2x, so I'll multiply it with a minus 2. That would give me a minus 2x square. There is no x, and I'm getting a plus 5. I made a mistake here, or what? I need an x square, so it is x minus 2x square minus 2x, because it would be keep on getting one after the other. It's x cube, x square, x, and then I change symbols. That would give me a 4x plus 5. I need to cancel the 4x, thereby multiplying it with a 4 minus x square minus plus 2x. I made a mistake here. It should have been a plus 2x, because minus 2x minus 1 is a plus 2x, and if I change the symbol, this would also get cancelled, thereby making or giving the remainder to be only 5. This is when we are multiplying this by x minus 1. This was this is the remainder. But the remainder theorem says if any polynomial px, this px has to be greater degree than equal to 1. That means it cannot be a linear polynomial. This px be divided by a linear polynomial, suppose x minus a, where a is a real number. Then the remainder will be p of a. So for our understanding, I write this remainder theorem and take up some applications. It says let px be any polynomial of degree greater than 1. That means I told you it is not a linear polynomial, and a be any real number. Then if px is divided by the linear polynomial which is expressed as x minus a, then the remainder is p of a. Let us learn some applications. Question reads is find the remainder when px is given as x to the power 4 plus x to the power 3 minus x2 x to the power 2 plus x plus 1. This is divided by x minus 1. Previously we directly divided and find the remainder, but here we can take up x minus 1, and so x equals to 1. So we replace p as 1. The question had said so. The theorem had said so. So it's 1 to the power 4 plus 1 to the power 3 minus 2 1 to the power 2 plus 1 plus 1. So it is 1 plus 1 minus 2 plus 1 plus 1. So 2 got cancelled. I'm getting a remainder which is 2. This remainder theorem can have a different application which would ask if to check whether, we take it up in the next screen, it says check whether a given polynomial, suppose 4t cube plus 4t square minus t minus 1 is a multiple of 2t minus 4. If 2, that means what? If 2t plus 1 is supposed to be a factor of 4 to the power t3, I mean this polynomial. Multiple means what? If suppose when I had said 10 is a multiple of 5 or 2, that means what? 10 is dividing 5 without leaving a remainder. The same application we do it here. If this polynomial is given as 4t cube plus 4t square minus t minus 1, this has to be a multiple of 2t plus 1. That means 2t plus 1 is the factor of this. When a number is a factor of a given number, that means when you divide that number, the remainder should be giving us a 0. That means if I should be dividing the given polynomials by 2t plus 1, the remainder should be 0. So that means here if applying the remainder theorem, I'll be taking t as minus 1 by 2. So here I should be getting a 0. If I get a 0 as the remainder, that means 2t plus 1 is a remainder. Sorry, is a factor, or is a factor. Otherwise, no. I am just quickly writing it down. Minus 4 to the power 3, that would be giving me a minus 1 by 8. Plus, so it is 4 into 1 by 4, minus minus plus 1. This is minus 1 by 2. This is plus 1, this is plus 1 by 2, and a minus 1. So all getting cancelled, thereby showing us that the remainder is 0. When the remainder is 0, that means this linear polynomial is a factor of the given polynomial. Thereby the vice versa, if we can say, this given polynomial is a multiple of 2t plus 1. There might be another question wherein it is changed oppositely, right? They would say, check if that is a factor of the given polynomial or not. We take up one more question, because previously I had taken a factor which was in positive. I'll take now a negative substitution. We have to find the remainder when the given polynomial, which is fx this is to be divided by the linear polynomial, which is x plus 2. So the remainder theorem would have to see if x equals minus 2 gives us a 0 or not. Sorry, we are not supposed to take it as 0 or not. We actually have to find out the remainder by substituting x to be minus 2. 6 minus 2 to the power 3. The same applied here. 2 to the power 4, so it is 4 for 16. 16 2 will be, I think, 32. 2 to 4 to 8, minus 8 and minus 6 is plus 48. So minus 2 square is 4 plus 2, that 4 into 2, that's 8. Minus minus plus 2 plus 2. So this will give us a big remainder. This is 2 to 4. So this is 50 and 10, that is 60, 70, 80, 90. 92 is the remainder. Okay. I hope you followed this quite well, because you might just be getting questions like, okay, I give you one question for you to solve and to check if you have followed it rightly or not. If the polynomials, it says, if the polynomial ax cube plus 4x square plus 3x minus 4, and these are the two polynomials I'm reading, they both of them leave the same remainder when divided. This, they leave the same remainder when divided by the linear polynomial x minus 3. Find the value of this a. I just help you and give you the hints. Taking x minus 3 a remainder for find out the remainder when x minus 3 is divided, dividing both these polynomials. You will get a different remainder for the first one and for the second one. As because that they are the same remainder, it says equate those two remainders to get a value for a. Happy doing. Bye bye.